Now I am going to cover the topic third generation neural networks like spiking neural networks, convolutional neural networks, deep learning neural networks, extreme learning machine model, and then in depth of how the convolutional neural networks are working, what are the layers are present in the convolutional neural networks, and then what are the basic algorithms used in convolutional layers, then what are the applications used in a convolutional what are the applications support by the convolutional neural networks. So these things to be covered in this topics. First one is the spiking neural networks. The spiking neural networks were introduced by the researchers at the Heidelberg University and the University of Bern, developing as a fast and energy efficient technique for computing using a spiking neuromorphic substrates. Specifically, the spiking neural networks, the first scientific model of spiking neural networks was introduced in the year of 1952 by the Aaron Hodkin and Andrew Huxley. Already we know that the human brain consists of 86 billion neurons, which is mainly used to communicate through electrical impulses that will be called as action potentials or spikes. The communication method in SNN will be done by using the spikes only. The SNN is very similar to artificial neural networks that closely mimic natural neural networks are known as spiking neural networks. A spiking neuron model is a neuron model that fires at the moment of threshold crossing, but it is mostly mimic the biological neural networks based on a structure and the computations what the computations in the brain, and the we are using learning rule for computations in a SNN. So this is the architecture of spiking neural networks. Here we are using an image. The image will be passed into the input layer, and then the input layer convert this image into the spikes. Then the spikes will be sent further into the hidden layer as well as the output layer. Finally we will get the spikes as the output, then it will be converted into the images. The spiking neural networks takes a set of spikes as input and produces a set of spikes as output. A series of spikes is referred to as spike trains. The main concepts of spiking neural networks are, uh, before going to understand spiking neural networks, first we have to know the basics of neural networks, that is as neurons and spikes, and then temporal coding. Next one, synaptic weights and plasticity. So neurons is nothing but the neurons is mainly used in each and every layer, which is used to get the pixel and pass the pixel to the next layer. So each and every layer consists of uh, numerous neurons. Next, spikes. Spikes is nothing but it is a uh, wavelength. It emits spikes based on its membrane's potential. Temporal coding. So SNN use the temporal coding where the timing of spikes carries information. Next one is the synaptic weights. Synaptic weights is nothing but that SNN are governed by the synaptic weights which determine the influence of one neuron spike on another. Next one is the plasticity. It was governed by the rules such as spike timing dependent plasticity. which allow these weights to change based on timing of spikes and enabling learning. So these are the mechanisms of spiky neural networks like membrane potential and firing threshold, synaptic integration, learning rule. So learning and the learning rule, uh, mainly we are going to use the uh, spike timing dependent plasticity rule. Next one is the neuron models. We are going to various models has been used, but SNN follow the these type, that is leaky, integrate and fire model and a Hodgkin Huxley model. So these are the main important model used in a SNN. Next one is the application of spiky neural networks. The SNN can be used in nervous system like uh, if a insect seeking food in an unfamiliar environment, if we want to predict this type of application or any food in an unfamiliar environment, we can go for a spiky neural networks. And also it is mainly used in computer vision, and they can be used to examine the operation of biological brain networks due to their realism. The main advantage of a SNN is a dynamic system. As a result, when SNN is already working, to train SNN you simply need to train the output neurons. Next, the main disadvantage is SNN are very difficult to train. Next one is convolutional neural networks. Convolutional neural networks was introduced Jon LeCun. So he's the director of Facebook AI Research Group. So he's introduced the convolutional neural networks in the year of 1988. So he built the first model which was used for character recognition tasks like reading zip codes and digits. So convolutional neural networks is an advanced version of artificial neural networks. So these things already we know that this is the one type of neural networks. So we have a three important types of neural networks like recurrent neural networks, convolutional neural networks, feed-forward neural networks. So CNN is also a advanced version of artificial neural networks. So which is primarily designed to extract features from grid-like matrix data set. So this is but particularly useful for visual data sets like images or videos where data patterns play a important role. So CNN are widely used in computer vision applications. So convolutional neural networks are referred to as CNN. It is a special type of neural networks. We already know that it is mainly designed to process and classify the images. Images means we can take a number, we can include numbers for in an image. So digital images are essentially a grid of tiny units that will be called as pixel. Each pixel represents the smallest unit of images, that is hold the information about the color and the intensity at a particular point. Each pixel is composed of three values like red, green and blue, that is RGB color channels. Each and every pixel in an image having these three combinations. These values determine the color and intensity of the pixel. So we are already also we have another image, that is a grayscale image. Each pixel carry a single value that represent the intensity of light at that point. So next, CNN always consists of multiple layers like a input layer, convolutional layer, pooling layer and a fully connected layer. Hereafter, we will discuss how CNN work and in what are the layers present in CNN. We have to discuss in a brief manner. So before that, we have to know the basic things of a neural networks like a neurons, input layer, hidden layer, and output layer. So neuron is a basic unit of a neural network. They are composed of some linear functions and non-linear functions known as the activation function is applied to them. So input layer, each neuron in the input layer corresponding to the one of the input feature corresponding to the input feature. Next one is the hidden layer, the layers between the input layer and the output layer. Each neuron in this layer is summed by the result of the neurons in the previous layer and multiplied by the nonlinear function. So next one is the output layer, the number of neurons in the output layer corresponding to the number of output classes. So this is one example of a convolutional neural networks. Here we have to use a digital image as an input that will be fed into the input layer. Then the input layer pass that pixels to the hidden layer. The hidden layer consists of multiple layers like convolutional layer, pooling layer, fully connected layer, and then it will be finally it will be connected to the output layer. So this is another example. We have an image like flowers. So in that we have a multiple flower images. By applying the convolutional neural networks, we can predict whether it is a orchid or rose. Next one is the image of a number image. So the number image also can be used, and by applying the convolutional neural networks we can predict the name of that number, and also symbol we can recognize the symbol whether it is a backslash or a front slash. So the smiley image. So this is the basic architecture of a convolutional neural networks. So in the convolutional neural networks, first we have a input image. Next one is the convolutional layer. Next one is the pooling layer. Finally, the pooling layer is connected with the fully connected layer, that is a dense layer. So the layers, the convolutional neural networks has multiple hidden layers. Uh, we see only one hidden layers in the convolutional neural networks. Multiple hidden layers that help in extracting information from the image. The main the four important or main layers in a convolutional network neural networks are convolutional layer. uh, Next one is the uh, ReLU layer, pooling layer. Next one is the fully connected layer. Finally, flattering layer. But the next final output layer. So these are the layers present in the convolutional layer. The important the hidden layer consists of a convolutional layer. That next one is the pooling layer and a fully connected layer. So these layers are combined, and we can take it as a hidden layers. So the first one is the convolutional layer. They are the fundamental building block of the convolutional neural networks. These layers perform a critical mathematical operation that will be known as a convolution. The process entails the application of a specialized filter that will be known as the kernel. The filter is known as the kernel that travels through the input image to learn complex visual patterns. They are essentially the next we have to discuss about the kernel or filter. They are essentially small matrices of numbers. These filters move across the image performing element-wise multiplication with the part of the image they cover, extracting features such as edges, textures, and shapes. So the main we multiply each term of the image by 3 into 3 matrix and pass it into an output matrix. The convolution operation. So this is the example of the convolution operation. The convolution operation has been done in the convolutional layer. The convolution operation involves multiplying the kernel value by the original pixel value of an image and summing up the results. Then we will get the one matrix. So that matrix will be called as the feature map. So we have to discuss some key points about the kernel also. Kernel always travels through the image matrix one pixel at a time. Not like that, the kernel based on the stride, it will scan. Uh, so sometimes uh, if the fix what happens with the pixels in the corners, we are only passing over them one time. What if they have an important features? And what about RGB images? We stated that they are represented in 3 dimensions. How does the kernel traverse over them? So these things will be discussed now. For that we have to start some important points, important concepts, or important components. We can say anything. The components are channels, stride, and padding. The above questions we have I have asked. I have raised some important questions regarding convolutional neural networks. For that, we have to know the important components like channels, stride, and padding. So digital images are often composed of 3 channels like red, green, blue, which are presented in 3 different matrices. For an RGB image, there are typically separate kernels for each color channel because different features might be more visible or relevant in one channel compared to the others. Next one is the stride. The stride refers to the number of pixels by which a kernel moves across the input image. For example, if we are choosing the stride equal to 1, so first it will scan the 3 into 3 matrix. Next row it will scan. If the stride is yes, the stride value is equal to 2, it will skip one row and then scan the next row. Next one is the padding. Padding refers to the addition of extra pixels around the edge of the input image. Whenever we focus on pixels in the images edges, we have to notice that we traverse them fewer times compared to those positioned in the center. The purpose of padding is to adjust the spatial size of the output of the convolution operation and to preserve spatial information at the border. So these are the important components we should know before going to convolutional layers. So if you are performing kernel with the input data, this operation is known as the convolution operation. This will be happened in convolutional layer. Then we will get the output as the feature map. that is the output of the convolution layer is feature map. So next one is the ReLU layer. So ReLU layer is a important one. ReLU stands for the rectified linear unit. Once the feature maps are extracted, the next step is to move them to the rectified linear unit layer. It performs an element-wise operation and set all the negative pixel to 0. If we get pixels like -1, -5, so that will be represented as 0. Then the positive values will be only represented as the positive side. So the main purpose of the rectified linear unit is to introduce the non-linearity to the network, and the generated output is a rectified feature map. Okay, that is a rectified feature extraction. So this is the graph of the rectified linear unit ReLU layer. This is the graph of ReLU layer. So this is the feature map, example of a feature map. Next one is the pooling layer. So pooling layer, we can see it as a downsampling layer or a pooling layer. So pooling layer is mainly used for the downsampling operation that reduces the dimensionality of the feature map. We can, if you have now, you have some question. Convolution layer is also used to reduce the dimensionality. This is not like that. The convolutional layer is the main purpose of the convolutional layer is to extract the features only. Pooling layer is only one layer which is used to reduce the dimensionality. So dimensions will be reduced with the help of the pooling layer. In fact, in most cases, we are not reducing the dimensions of our data because we are creating new channels that weren't that before. So even if our feature map dimensions are smaller, we have more of them. So now we are going to discuss how the pooling layers are working. If you imagine you have a large image and want to make it smaller but keep all the important features like edges and colors. So the pooling layer operate independently on every depth slice of the input. It resizes it spatially using the max or average pooling of the values in a window slide over the input data. In pooling, we are not applying any kernel to the input data. We are just simplifying the information with the max operation with a max pooling or a average pooling. So the pooling layer do not reduce the number of channels. Each pooling operation is applied independently to each channel of the input data. So this is a good representation. Here you can see how each pooling layer is reducing the dimensions of the spatial space, but it is not reducing the number of channel. So just to remember that it is mainly help to reduce the dimensions spatial space or a dimension of the spatial space, not a channel. So after convolutional and pooling layers have extracted relevant features from the input image, we have to turn this high dimensional feature map into a format suitable for feeding into the fully connected layer. So we already discussed the types of pooling. So we have two types of pooling, that is a max pooling, average pooling. Maximum always researchers prefer max pooling for a pooling layer when compared with the average pooling. So next concept is the flattening. Imagine you have a grid of data like pixels in the feature map. We want to line up all of these grid points in a single long line. That's what flattening does. It takes the entire feature map, and reorganize it into a single line, that is a long vector, single line long vector. The main purpose of the flattening is converting these vectors grid points into long vector. This is the important Why the flattening means the integration of features. By flattening the feature map into a vector, the network can integrate the spatially distributed features extracted for tasks such as classification. So next one is the fully connected layer, and also why this flattening also important means the fully connected layer are designed to operate on one-dimensional data. Hence, flattening is a necessary step to transition from the multidimensional tensors produced by the convolutional layer to the format required for a dense layers. While convolutional layers are good at detecting features in input data, dense layers are essential for integrating these features into predictions. For example, if we design convolutional neural network for a facial recognition, early layers may detect edges and textures, while dense layer might interpret these to recognize specific facial features. Without a dense layer, that is a fully connected layer, CNN would not be able to perform the high level tasks that are often required, such as classifying images, detecting objects, or making predictions based on the visual inputs. So, fully connected layer is also very, very important, and mainly it is used to decrease the risk of overfitting and also makes the networks expensive. So finally, we have to conclude that up to this point, we have revised the CNN structure. So what are the CNN structure includes like convolutional layers, pooling layer, flattening layer. Finally, we have a dense layer, that is a fully connected layer. And also we have to notice that the fundamental concept of channels tried and pooling. So we can say it as the activation layer, and also we have some extra layers like input layer, flattening layer, output layer. So these layers will be called as additional layer. So next one is the key aspects of CNN. It have a grid-like topology and feature learning. It follow the feature learning concept and also spatial hierarchy of features. So the main advantage is automatically learn features without manual extraction, and it uses the shared weights, and easily we can recognize the patterns, and it uses to capture both low level and high level features, and also it is versatile and applicable for images, audio, video, and text. The main disadvantages are require high computational power and resources, and also large amount of labeled data for training, and it can overfit. It required fixed input sizes. So till now we have discussed spiking neural networks and convolutional neural networks. Thank you so much.